There we go. Um, okay, as I was saying, this is a national program and it is good for the entire country, but California has a few areas where they are special or they're a little bit more advanced. So what I've actually done today in this lecture is I've hidden anything that's not relevant if you're in California. So there's a few slides as you get into it that say, this is not for California, this is for everybody else. I'm not even going to talk about that today because you're already trying to learn new things. Why should I tell you new things that are not the thing? So I'm trying to kind of simplify and streamline. And ultimately, the number one question we are trying to answer today is, how much should I water my plants? You think that would be an easy question. It's a very difficult question. How much should I water my plants? If you're only taking care of house plants or a few, individual plants, you watch the plant, and when it starts to wilt, you give it the water. But if you're taking care of a larger landscape or a garden or a field, you need to kind of use some numbers to figure it out. And several years ago, when the drought was very extreme, some of the local governments, they put restrictions. They said you could only water your yard for 5 minutes 3 times a week. And then if you were in a different water district, they said you can only water your yard for 10 minutes each, but only 2 times a week. And neither of those make any sense, because if you have drip irrigation or if you have, a fire hydrant releasing water, you could run both for 5 minutes, and that's going to be very different. So not many people understand how to properly determine how much water to give. That's going to be the goal for the day. Click in here. So the learning objectives, we describe water use in the landscape from kind of like accounting, using the terminology that accounting would use. So you have a budget and you need to be within the budget. In order to determine the budget, we look at nature, we look at evapotranspiration, and that data comes from weather stations. We look at the plants themselves and how much water they use. And then we look at the landscape area and we figure out how big it is and how to calculate the basic water budget. From there, you figure out how much irrigation water to apply so that you are within your budget. So that's what we're going to be talking about today. We're going to take a break after after we make it through the first kind of chunk. The first chunk is this water budget. Then we'll take our little break, and then we'll come back and talk about how to spend the water so that you're within your budget. And this is, again, this is a national program. California has a few more stricter restrictions, but I do like the way Quell introduces this concept because I think it's easier to understand. So again, if you have questions, feel free to ask at any time. But basically, the whole point of a water budget, it's an estimate of how much water you need to maintain a healthy landscape for a given period of time. So every year you've got a budget, every month you could have a budget, and it will change throughout the year. Obviously, you need more in the summer, you need less in the winter. And they're very important. You use them for managing your landscape, not only to take care of the plants, but if you irrigate according to a water budget, now you can actually take a look and see how much money you're spending, how much water you're spending. And if you want to make any improvements to irrigation systems or to the choice of your plants, you can actually compare. But if you don't ever manage it, or if you don't watch how much water you're using, you don't really know if something's drought tolerant or not. So we do this for two reasons. First of all, we want to make sure everything is healthy and alive. Second of all, we want to be able to make good decisions and make improvements over time. So there are three basic elements of a water budget. And this is the thing that if you're writing anything down, you should write this down here. This is such a simple concept, but it's something that most people don't do, even the professionals, even the people who work on irrigation, they don't do this. And so basically we need to know three general things to determine the water budget. We need to know what the weather is like. We need to know what type of plants we have, and we need to know what the area is. With just those three things, we can determine how much water our garden needs. So we'll explain each of these in this next section, and we're going to go into detail. But remember, it's just these three things: the weather for your area, the type of plants you're growing, and the area itself. And the budget is always measured in inches, which is a strange way to measure in water, because it's kind of like how we measure rain. So when we measure irrigation, we're measuring it the same as rain. If you get, a 1/4 inch of rain, for example, that's like, we convert that to irrigation. We think of it the same way. But you could come up with it in gallons, because as we learned 2 weeks ago, that's how we're either paying in gallons or cubic feet, 100 cubic feet. So they put in these cheesy little quick review questions. So here's our poll. What are the three elements of a basic landscape water budget? Who wants to be brave and shout it out?
Weather, plant type, and area.
There you go. Oh, sorry, I didn't give you the
Oh.
options. So the options look kind of crazy. Soil, plant type, weather. But JR, you got it right. Weather, plant type, landscape area. So which one would that be? That would be D, wouldn't it? So notice that the irrigation type and the soil type make no difference in terms of the budget. They'll make a difference later on, but when it comes to how much water the landscape needs, we don't think about those other things. We just think about the weather, the type of plants, and the area. Any questions so far? Okay, we've got the three things. All right. So in order to talk about weather, we mainly talk about evapotranspiration, because evapotranspiration is how water is lost in the environment. So remember earlier I said, forget about growing the plants and grow the soil. This is kind of along those lines. You can think of the soil like a bathtub. It's full of water. The soil is always full of water. In fact, the soil will never not have water in it. Because the rocks and minerals are so small, they actually collect water right out of the atmosphere. So as long as there's any air with water in it, which there always will be, there will be some water in your soil. That doesn't mean it's all available to your plant, but think of the soil like a container of water. And that water gets lost over time as it dries out and as the plants use it. So instead of trying to just, pour water all over the plant, we're trying to think about our soil in the landscape. How much water have we lost since last time? And so therefore, how much water do we have to add to fill it back up? You know, just like a bathtub, you if you let it overflow, if you fill it up too much, it's going to run off the sides, and or it will even run off down the drain and go really deep. So we don't want to lose water deep past the root zone, and we don't want to lose water over the sides, but we do want to fill up the water all the way in the soil to what's available to the plant. So that's where this concept of evapotranspiration comes in, because that's how water is used or lost in the soil. We abbreviate evapotranspiration with ET. So ET, evapotranspiration, and it's a word that is a combination of two words, evaporation and transpiration. We're familiar with those two words usually. Evaporation is part of the water cycle. That's where water goes from the earth up into the sky. Normally we think about it happening in the ocean, but it also evaporates from the soil. So if you have water in the soil, you will have some evaporate. And the other way we lose water in the soil is when the plants grow. So the plants take in the water, and then they also exhale the water to the atmosphere. That's required. They have to do that for photosynthesis. And when they exhale water, that is called transpiration. They are transpiring water. They're taking it from the soil and they're releasing it to the sky. So when you combine those two, we have all of the water lost in the soil in the form of evapotranspiration. And that is a unit of measurement. It's something that we can look up and we can figure it out. So it's a natural process, and it's an important one for that first piece of our puzzle, or of our formula, weather, evapotranspiration. So what affects the transpiration and evaporation? Many things. If it's in the sun versus the shade, the sun will have more evaporation and transpiration. If it's a hot day, there will be more evaporation, transpiration. If it's very dry, there will be more evaporation, transpiration. And if it's very windy, if the soil is exposed, or if the plants are very dense, closely planted, all of those will have more water lost to the soil. So these are all factors. You don't need to go and measure each of these things, but you do need to know the overall evapotranspiration. And it changes day by day. If it's a rainy day, you probably notice that you don't need to water your plants. First of all, they're getting the rain, but even if it's just kind of cloudy, the plants don't really use up too much water. But if it's very sunny, obviously the plants will use more water and you'll be losing more water. So if you have a weather-based controller or a smart controller on an irrigation system, sometimes it'll do some of this measuring it by itself automatically. But even if you don't, this is the kind of information we use to help determine how long to run the irrigation. So we don't collect the actual evapotranspiration. That's really hard to do because what are you going to do? Go like put a plastic bag on your plant and see how much water comes out? It's really difficult to determine the actual amount. There's no good like sensor or instrument to detect it. So what we do instead is we guess. And in order to make a good guess, we use a reference. And the thing we use is cool season grass. So there are places throughout the country where they grow grass, cool season grass, which is a certain kind of grass, and they keep it well watered so that it's growing well. It's 4 to 6 inches tall, and it's kind of in like a field where they can carefully measure how much water comes up off of it. And that is the thing that determines everyone else. So when we're comparing our garden to the evapotranspiration, we're always comparing it to a grass in a cool season that's 4 to 6 inches tall. So that reference ET, it gets a special abbreviation, ETO. And I wish they picked better abbreviations, because ETO doesn't seem to make sense. But when you see ETO, that is how much evapotranspiration do you get when you have grass. So it can be measured over any period of time, but usually it's per month and per year, ETO. So this ETO is the weather component of the formula. Any questions so far about this? Yes, Hunter.
Is more water lost through the plants or through the soil?
Well, the only way the water is lost is through transpiration or evaporation. And so if all of the soil is covered by plants, then more of it is through transpiration. If you have plants with exposed soil, then you're going to lose some from evaporation too. That's one of the reasons that in sustainable landscaping, we always recommend mulch on the soil, because we don't want to stop transpiration, because that's plants. You need to have the transpiration, but we can stop the evaporation. So anti-evaporation strategies are the definition of sustainable landscaping in San Diego. And so what you're doing is covering the soil, you're using organic matter. All of these are things that help the soil retain water, because you want the water for the plants. You don't want the water to go away in evaporation. So it depends, but it's hard to tell the difference. That's why we combine them to this single variable called ETO, because it's just the combination of evaporation and transpiration. That's a very good question.
Mark, I do have a question.
Yes.
In that water budget calculation where it says plant type, is that factoring in transpiration on the plant type?
It is.
More so?
Yes.
Okay.
So we'll get to that, but
Okay.
basically a little preview is that cool season turf grass is the most water thirsty plant you can grow. So nothing needs more water than cool season turf grass. That's why it's the reference, because that's 100%. So if you're growing any other kinds of plants, it's probably going to be less than cool season turf grass. So anytime we add the plant type to the formula, we're going to be taking the weather amount. Remember, that's the water lost. And we're going to be also subtracting any savings from our plants, because our plants are going to be more drought tolerant than cool season turf grass usually. That's why we use that as the reference. It's kind of the baseline. Okay, very good. Let's continue on, and we'll explain how they get the weather data a little bit more. We're going to look at some numbers, and we'll make sure everyone understands what we're talking about. So what is the source of ETO? How do they get that number? There's a couple different ways. Let's take a look at them. First of all, there are weather stations set up throughout the county and throughout the entire country, and they take data. So we have them here in San Diego. They look like the image on the right-hand side. That's the weather station. Pretty simple. You better hope no high school kids go and tip it over, because it looks like it's pretty easy to do that. A lot of people think a weather station should be a giant building or something, but this is all it is. So what it's doing is collecting the wind speed. It's measuring any rainfall that occurs in that area. There's temperature, there's humidity. There are a variety of sensors that are all linked to satellite and internet. And so we're measuring what is it like in that specific spot. And if we put enough of those out, we can get kind of a good average for the whole state or the entire San Diego County. And so this is one way that they get that number. It's not up to you to go figure out the number. You're going to look up the number. And where are they going to get it? Well, part of it comes here from the weather station. Every day, it's basically instantaneous. So you could go to a little website and you can see exactly what the data is on the weather station that day. And again, if you have a smart controller that's hooked up to the internet, it's going to be actually able to use this data on a daily basis. So you don't have to determine how long to make it run. It's basically what it's going to do is take yesterday's data and then apply it to today's watering. And then tomorrow it'll be looking at the day before. So every day it comes up with a new kind of amount. And that's too much work for you to do by hand. So normally you would do this on a monthly basis if you're just doing it manually. So you do it 12 times a year, or at least 4 times a year. So over time, we do this day after day, year after year, and you get some pretty good kind of trends with the weather stations. So here's all of the things they're measuring: the wind, temperature, as I said, the amount of solar radiation, if it's a cloudy day or a sunny day. Where do we get our data? California is unique by state. We have excellent data for the weather systems just for irrigation management. And so the resource is called CIMIS, CIMIS, California Irrigation Management Information System. What a boring name. It sounds like an engineer came up with it. That's because the irrigation people, they're kind of like engineers. They're very mathematical in how they think. So this is a statewide resource that's operated by the California Department of Water Resources. They have over 145 weather stations, just like the image I just showed you. And basically they have used that to come up with different climate zones that they have observed over time. California can be divided into 18 climate zones, and this information is free to access all the way back to 1989. So over time, you can see not only what is the average temperature for this time of year, but how has it changed over the past 30 years now. And the website is down here, cimis.water.ca.gov. We don't need to waste too much time going through that, but I do want to show you what it looks like when you go to the website. It's kind of an old school looking website. You can get all the data and all that kind of stuff. But here's a map showing you the different zones in California. So do you see the different colors? Each color is its own unique climate zone. And this is based on the weather data that's been collected. If we zoom in down at Southern California, look at San Diego County, you can see we have 1, 2, 3, 4, 5, 6 different colors in San Diego County. And they're more or less vertical lines. What that means is as you go further away from the ocean, you go into a different climate zone. And if you've driven through the county, you know that you start out on the west side at the ocean. Right by the ocean is very different than a little bit inland. So if you're right on the ocean, it's nice and cool and always a little bit foggy in the summertime. You get June gloom and it never freezes, never very cold. As you start to go in away from the ocean, it gets hotter in the summertime, cooler in the wintertime, maybe some frost. As you keep driving, you hit the mountains. The mountains get very cold, you get snow. And if you keep going past the mountains, you hit the desert. The desert is on the other side of the mountains, very dry, very hot. It's actually below sea level and very different climate still. So we have those 6 different zones in San Diego, but the entire state has 18. And you can kind of get an idea that if you travel throughout the state, you could always refer back to this to kind of give you some ideas on where you are and what it's like there. Basically, you can see the coastal zones quite similar all the way up. And then as you go inland, it's always going to be hotter and drier. And the colors, they sort of correspond. So just that alone is a good resource. Very good for you to be able to refer to, especially if you ever move to a new place. You can kind of learn very quickly where you are in the state. So let's look at this data that CIMIS provides. We saw the map just a second ago, and I brought it up because otherwise these colors wouldn't make as much sense to you. So I think it's important to see the map. So here's a description of the different colors. And you can see we've got zone 1, the coastal plains, the heavy fog belt. And then zone 4 is the South Coast inland plains. That includes kind of the Balboa Park area. Zone 6, the upland Central Coast, LA Basin, Miramar. And then zone 9, South Coast marine to desert transition, Otay Lakes, Escondido, inland area. And then we head on east to the desert. Any questions about that so far? I think it's always a good idea to get to know where we live and get to know it in detail. So I appreciate looking at these maps and kind of thinking about our home place in a unique way. So here's a wall of numbers, and it looks scary to me because what the heck is that supposed to mean? But let's break it down and let's just, without needing to memorize anything or needing to worry about this too much, let's try to see what we're actually talking about here. These numbers are telling us how much evapotranspiration, so how much water is lost. The units are inches, so inches of water. How many inches of water are lost from the soil? And here it's every month. So the column is the month, the number is the inches of water, and the different colors on the left-hand side, that's the zone. So where in California are you? Just looking at these numbers, what are some observations you can make? We don't need to do any math or anything technical right now, but what can you tell me about the nature of water loss in the soil throughout the year in these various parts of California? Does anybody see any pattern emerging in the numbers? Hunter, go ahead.
It seems to be lower in the cold months.
Yes. So in winter, for example, take a look at the first column, January. All the numbers are 0, 1, or 2. You compare that to the summer months, June, July, August, they're up above 5, 6, 7. So that makes sense, doesn't it? Can anybody tell me what is the month of greatest evapotranspiration? Go ahead and shout it out.
Looks like July.
It's July. And JR, is it July for every part of the state?
It seems to be,
Yes.
yes, it looks that way.
So that is an interesting thing to observe. July is the month where we lose the most water in the soil, no matter where you are. Even if you're up in the mountains or in the desert, or if you're on the coast, you're always going to lose the most water in July. Any idea why?
Generally the warmest time, the driest time.
It is usually the warmest, driest time, but there's one variable that never changes, and it's the variable that has the greatest impact on evapotranspiration, and it's the length of day. July has the longest days, and whether or not you have a rainy day, a cold day, a cloudy day, July is going to have the greatest hours of sunshine, so that's going to lead to the greatest evapotranspiration. This is useful because if you only were going to set the controller one time, what month would you set it for? Set it for July, because at least you'll keep everything alive at the hottest time of the year. That's what most people do. They just set it for July. And then in the winter time, you just keep it at July settings, and you're going to have a little bit of wasted water, but at least everything's going to be alive. So that's the old way. The old way was, what's it at July? And that's what we're going to do for weather. Then the other thing to notice in the total column is the overall number. So that's how much water is lost in California in inches. It ranges from 30 up to 70. Does anybody know the average amount of rainfall we get in San Diego? Make a guess.
Nine.
Yeah, basically that is correct. So if you're on the coast, 10 inches is the average in San Diego. Like if you're at the airport, that's technically the 100-year average at the San Diego airport is 10 inches a year. So that would be zone 1. They get 10 inches a year, but they lose 32 inches a year in evaporation. So that's what makes San Diego a dry area. There's more evaporation than precipitation. In January, however, they get more than 0.9 inches of rain. So in the month of January, there's more rainfall than there is evaporation. But in the overall year, we know we're gonna need to irrigate. We know we need to water our plants, because if we don't, we're gonna be losing at least twice as much water as we get from the rain. So those are the kind of lessons to take home. July is the greatest evapotranspiration. but it follows the general pattern of temperature throughout the year. It's based on the length of day, and it's always going to be more evaporation than precipitation in California. Okay. Here's a graph that just kind of shows that exact thing. So these are the different colors are the different zones, and it's showing how the evapotranspiration is always going to be lower in the winter time and highest in the summertime. And as you go out to the desert, the peak is going to get steeper, more evaporation in the summertime. This is a, what kind of average is this? It's 25-year average. And if we compare that general curve in blue, the ETO curve, to the rainfall amounts throughout the year, you can see they're basically the opposite. So we get a lot of rain in the wintertime compared to evaporation. And then starting right about now, it flips and we start to get more evaporation than rainfall into the summer where we get zero rain and we have maximum ETO. This is why collecting water in rain barrels is good, because in the winter time when it rains, it's extra, you don't need it. And if you can hang on to it into the April, May, June months, it's actually going to be very beneficial. This is different than most parts of the world. Almost every other place, they get a lot of rain in the summertime, but we don't get any rain in the summertime. That's why growing things in California requires this special attention. Okay, quick question. What does ETO stand for? You can read the answers there, A, B, C, or D. Reference evapotranspiration. Oh, never mind. These are boring questions. Extraterrestrial, efficient timing, exclusive temperature rating. I think you all could tell me the answer to that, couldn't you? Hey, I don't like when they don't even respect our time. It's obviously not extraterrestrial, although that is a good movie, E.T. Okay, how do you feel about that? Overall, what do you think? What are your impressions? I'd like to hear a little something about that first part of the formula, weather. Is it more technical than you thought it would be?
No, yes and no. Like there's certain aspects to it that's more technical, like when it comes to the wind speed or, like stuff like those type of factors. But when you think about like, oh, how hot it is, the temperature, it makes sense. Like, so yes and no.
Yeah, it's a very complex thing in nature. So yes, but then also we've reduced it to one number. So yes, it's kind of a number that just doesn't always help you understand what's happening, but that number is something that's going to be very useful. And we only have to worry about one number. And yes, it'll change based on the weather every day, but basically it's the same. So if you have that chart, you can just use that chart. And for that month, that's the chart you use. Don't worry about whether it's sunny or cloudy every single day. Just go back to that chart because it's not going to change very much on a day-to-day basis. So that's the good thing. JR, Hunter, any questions, any considerations?
Well, I was going to say, number one is working at a golf course. We do have a small weather station like that. We collect data such as precipitation, which is huge for us. And we're right there next to the ocean. And so we kind of pick days on our water windows when we irrigate, when we don't. And so that's a real big factor for us in that. And so weather is certainly, the winds are a certain factor, definitely a factor for us. on when we're mowing so it affects us in a way. So that reading all this just kind of brings me home with what I actually do.
It would be
Or more,
nice,
yeah.
JR, to learn. You may know offhand. Do you know what kind of irrigation controller you use?
We use a Toro system, a hydraulic irrigation
Okay.
system. Yeah, and so I don't actually handle any of that. I just do audits on some of the actual sprinkler heads, and make sure that it's working functionally, and I don't need to repair them.
Have you
I don't know.
seen the computer and how it does controllers? Because
Oh,
it's
yeah.
probably a bunch of numbers on a
Oh,
page,
yeah,
right?
it's a bunch of numbers. It's allocated to certain areas and groups. And if you hit the wrong one, you can probably jet yourself with a pretty good sized sprinkler. Yeah,
Yeah.
these things are heavy duty. They have pretty good range. But yeah, they're very complex. And we have a handful of guys that handle that on the course. Yeah.
So that's a good point that you bring up. All of that stuff can be very technical. There's a lot of sensors and data, but the thing we just covered is the foundation for all the controllers that are out there. So the controller you use at your golf course, it's running with this as its background. The CIMIS data is kind of the foundation. And whether you put a little extra or a little less, that's what all the other sensors are for. But it's basically gonna, if all your sensors got turned off, it would just only go back to the CIMIS data and do what that number tells it to do. Everything else is just to adjust a little bit. And that's actually what the next category is. We're adjusting for the weather based on our plants. So the plant water use classification. I think they should give it a better name, like drought tolerance or something like that. But let's talk about the plants, and we'll show you that there's a resource just for plants, just like there's the resource for the weather. So here we're going to the next variable in the formula, the plant type, and they call it plant factor. Because if you remember back to, like, I don't know, third grade, when you started to learn multiplication, they call those numbers factors. When you multiply something, it's called a factor. So we take the ETO and we multiply it by a number based on the type of plants we use. So that's called the plant factor. Remember, our baseline is cool season turf. So we're always comparing our plants to cool season turf or grass. And so it's going to be a certain percentage of cool season turf. Cool season turf is 100%. Most of your plants are going to be less. So that percentage is going to get converted to a decimal, and that becomes something you can multiply against the weather. So here's the example. If it uses 80% as much water as grass, then the plant factor is 0.8, because you multiply the ETO times 0.8, and you'll only be needing to water 80% of what you would be needing to water. So it's very simple, but it can become kind of technical with the way we talk about it and the way we treat these numbers. But as we go through, feel free to ask any more questions about it. I want to make sure you understand. So there's another resource. It's called WUCalls, and they love their acronyms. I think it's too many letters. Water Use Classification of Landscape Species, WUCalls. So this is how you know if something is a high water plant or a low water plant, if it's drought tolerant or not. So everything has been given a category: high, medium, low, or very low. and the corresponding percentage compared to grass, you can see is laid out in the table. So if it's a high water use plant, you're somewhere between 70 and 90%. And if it's a very low water use plant, you're using less than 10%. You can see examples of the plants there. So instead of focusing on the slides, I want to just show you the website once again, because I think that's more valuable. If you go to WooCalls, put that into Google, you'll see the plant search database. So this is what it looks like. And I already selected Chula Vista. So every city in California is here. And when you select Chula Vista, all it does is it puts you on the map that we just saw, CIMIS. It's going to find the proper evapotranspiration for that area. So there's several ways to use the database. If we are looking for like a low water use plant and we know that we want to see a tree, you can type low tree, type in your city, and then you can search for all the plants that are appropriate in that category. A huge long list. But let's say you have a landscape and you want to know, what is that, a drought tolerant plant or not a drought tolerant plant? So you can go in reverse. So let's do an example of that. And in order to do that, let's use a plant. Somebody say the name of a plant. Any plant. It could be a common name or a scientific name, but mainly a plant that people put outside. Can you think of one?
How about a like a trailing lantana?
Okay. I'm just going to type lantana and then we're going to see everything that it tells us. So we search. We have 5 results with the name lantana. They're listed as either ground covers or shrubs. And trailing lantana, Lantana montevidensis, you can see low water use. If we open it up, there's a page just dedicated to that plant. And you can see a little description. And here it shows you the different regions. So we had selected Chula Vista. So it's highlighting South Coastal because that's where we are. But if we had selected a different area, the value might be different. So do you notice how if you're in region 3, South Coastal, then this lantana is a low water use plant. But if you go out to the desert, this plant becomes a medium water use plant. So you need to water it more in the desert than you need to water it on the coast, which that makes sense. That's intuitive. But there we go. Valuable information. And just so we can remember, low water use is 10 to 30% of ETO. Medium or moderate would be 40 to 60% of ETO. And I wish they didn't give a range because that's not useful. So what I tell people is just call that 50%, call that 25, call that 75, and then you'll be okay. So if you wanted to, if you really love this and you're like, wow, this is great, you could just go crazy. Don't put in any data. And you can download the entire thing. Whoa. And who wants to do that? Well, anyway, here's the information. It's called WooCalls, Water Use Classification of Landscape Species. Okay, questions? Yes, Hunter.
Has this information been around for a while, or is it becoming popular?
It's been around for a while, but it is only popular among some people. So it's not really something that a homeowner is going to look at. It's more for the landscapers. Anyone who's running irrigation should look at it, and anyone who's designing the landscape is going to look at it. Because the new rules in California, they require that you use drought tolerant plants. And they have a similar rule for building new gardens. In order to get a permit for landscaping, it has to be a certain percentage of ETO. And so just how we consider running the irrigation, the new gardens, they have a requirement that it must, depending on the circumstance, it has to be a certain percentage less than cool season turf. You can't just cover the whole thing in turf. And so all of the landscape architects and the landscape designers these days, they're very concerned with, oh, is that a medium water use or a low water use? Because if it's low, then you get to use it. If it's medium, you have to be careful on not using it. And if it's a high water use plant, you don't even get to use it, basically. It's out the window. So when you hear people, professional people talking about this medium, low, or high, they are referring to WU calls. And this is the 4th version. They always update it and kind of add a little bit here and there. So that's a great question. All right, let me go back to the presentation. I like to show you the actual resource instead of just kind of talking about it, because it's not that difficult to use. And I think I encourage you to look at it, to use it. You have the slides and you have the website down here. You could always Google WU calls and it's going to tell you exactly how to find it. It's a really valuable resource when people ask you questions. Okay. So here's just a table showing that the different regions, they're linked to the different CIMIS zones, as well as to the sunset climate zones. A lot of people are familiar with those too. And different cities in California, they kind of fall in these different general regions. So that's how the information is calculated. And where is San Diego? We're number 3, South Coastal. And here's the website that I just showed you. And I guess when they do this, otherwise they only just show pictures. There's other ways you can get plant water needs if it's not on WU calls. You can look up information with the master gardeners. You can get information from us. We're a pretty good source, I must say. Nurseries will help you out. Some city or agency publications have data. And then the Western Garden book is listed as a resource. Unfortunately, it's out of print, but if you're gonna do any work with plants, I recommend you try to find it. Get it now while you can, because it can be, you know how used books on Amazon can be like randomly $100. So they stopped making a book version, but it's still a very good resource to have. It's like an encyclopedia of plants. I highly recommend it. And Sunset has their own type of climate zones. So if you take a class with Plant ID, you will have to look at some of these maps. Same concept, but it's beyond California. It's the Western Garden book. So this looks like something that pretty accessible, easy for people to have. It kind of looks like a for the general public, but it's very technical and it's a very good resource. So it should live on your shelf. I actually, if you can see, I have got like all the old versions too. So The reason they're so expensive on Amazon, I buy them all. So many other resources out there. And if you don't know, you kind of have to just guess. But we use those categories: low, medium, high, very low. So in general, if you don't know, there's a few things you can look for. Usually the water conserving plants, they're going to have smaller leaves or like really leathery or tough leaves. Those are drought adaptations. They might have waxy or hairy leaves. They could be like a succulent. They could have gray foliage or kind of a white color on the leaf, or fleshy stems. All of those are drought tolerant adaptations. And if you observe those in the landscape and you don't know the name of the plant, that's a good indicator that it's a drought tolerant plant. And if you're looking for edible plants that are low or moderate water use, pomegranate, peach, plum are good ones. I would also recommend grapes, olives, any of the things that come from like Spain or Italy. Those are going to be perfectly drought adapted to our climate. Okay, questions about that, about plants? All right, we're gonna go through the last section and then we'll take our break because I want to give us a chance to, walk away from the screen. There's a lot of info here, but I don't want to stop until we get through this kind of concept of the water budget. So next we look at the hydrozones. This is where we're going to start talking about the last piece of the puzzle, the area, the landscape area. And we break the area of the garden up into subgroups. The groups are called hydrozones because we want to group the garden according to water use. So we want the low water use plants to be grouped together with the medium water use plant, or separate from the medium water use plants. And this way, when we run the irrigation, we can be efficient. We don't have to overwater or underwater something. And usually in an irrigation system, you'll have different valves like number 1, number 2, number 3, and they should turn on separately for these different hydrozones or these different water usages. Many different things would determine whether or not you have a hydrozone, but they should all have similar plants, similar soil, similar sun and shade, and similar slope. All the other stuff, it's going to vary day by day, but in general, if you've got a really sunny spot, then you have drought tolerant plants. That's a hydrozone. If you've got a shady spot, that's its own hydrozone. If you have lawn and grass, that would be a separate hydrozone than if you have trees and shrubs. You try to only group things together when they have similar water needs. So here's just showing some examples. High water use plants are those things like ferns, willows, most of the annual flowers. Medium water use would be shrubs, camellias, roses, pittosporums, Raphiolepis, agapanthus. Low water use would be the Mediterranean type of plants: strawberry tree, bottlebrush, manzanita, ceanothus. And then the very low water use are the California natives. Basically, the only things that are, they don't need any irrigation at all. And these would be the things that are common to San Diego: Dudleya, California fuchsia, manzanita, ceanothus, buckwheat. There's many sages and many, many examples. So let's take a look at the calculation for area. Remember, it's the last variable in the formula or the last piece of the puzzle. We go in area by square footage. So usually that's length times width. Pretty easy to measure. You measure the length on one side and the width on the other. You multiply them together. So a couple of examples just to help illustrate the point. If you have an area that's 100 feet long and 10 feet wide, you multiply those two, and that's 1,000 square feet. If it's 80 feet long and 30 feet wide, you multiply them, and it's 2,400 square feet. So notice in our formula, we're trying to turn everything into a number because that number is going to tell us ultimately the water budget. So here's a quick little quiz. A hydrozone measuring 50 feet by 75 feet has an area of blank. What is the area if it's 50 feet by 75 feet? Pull out that calculator.
3,750 square feet.
3,750 square feet. Let's take a look. 50 times 75 is 3,750 square feet. Yes, very good. So when it comes to these hydrozones, you never want to mix high water use plants with medium or low water use plants. In fact, nowadays, I don't recommend you rip out plants in general. Like, don't cut down a tree if you don't need to. But if you're going to select a new plant, don't pick anything on the high water use list. Stick to the medium or low water use plants. And you'll always have to use the highest water use for that zone if it's mixed. So say you have a mix of medium and low, you'll have to use medium, because if you don't, you're going to kill the medium plants. So you always go with whatever's the highest plant. So say you had a bunch of like cactus and succulents, and then somebody plants a weeping willow right there. Well, the weeping willow is a high water use plant. So now you have to water the whole thing like a high water use plant. When I was a kid, one time I had a pet lizard. I had one of those anole or anole lizards. And then I went and I got a lizard from the outside, a Western fence lizard. And I just put that in there so they could be friends. And I didn't realize they had different water use requirements. One needs the enclosure to be misted all the time. The other needs the enclosure to be dry. And they ended up not doing well together. So whenever I think of these hydrozones, I remember my poor little lizards that I had as a kid. I did release the Western fence lizard after a little while. So anyway, just remember that you're always watering to the plant that needs the most water, which is why you should group them according to water needs. So how do you select the plant? Well, you consider lots of things. You look at the environment, the microclimate. You think about the size, the mature size, the growth rate. And then you look at, is the plant going to help out the environment? Is it going to provide shade? Is it going to block the wind? Do I need to have a screen for privacy or erosion control? And then you look at the regulations, as Hunter kind of introduced the idea that how do you know what to pick? Well, in new landscapes, we have to look at those numbers, and we got to be thinking about reducing our water use. So many factors go into selecting the right plant. Let's take a look now as we wrap it all up at the water budget calculation. We take our three variables and we put them together. So we take the ETO from CIMIS. Remember, the reference evapotranspiration is in inches. And we take the plant factor, which is a percentage. So we convert that to a decimal. that comes from WUCalls. Then we take the landscape area, and that's in square feet. And all of these units are different. So we need to convert these different units into something that makes sense for water. And for water budget, we use gallons. So the conversion factor here to go from inches to gallons per square foot is 0.62. So here's just an example showing how to fill it in. We need to find the ETO. You find your zone and you find the month. Here it's showing 6.51 for July. And then we take a look at the water use. And if we're going to have grass, it's going to be somewhere between 70 and 90. So a Bermuda, for example, would be 70. It's a little more drought tolerant. And then the landscape area, you go around and measure it, you figure out it's 1,000 square feet. So you put all of those factors in and you multiply and you find that the water budget is 3,229 gallons. And what length of time is that for? What can you tell me? How long do you have to spend that water? Over what period of time does the landscape require 3,229 gallons?
Just during that specific month.
Exactly. Because we use the ETO for July, then in the month of July, our 1,000 square feet of grass is going to need 3,229 gallons. So do you remember how gallons was measured on the water bill in 1,000 gallons? So your water bill would go up 3 numbers in the month of July by watering this piece of grass. So let's compare that to one that's more drought tolerant. And we'll see how big of a difference drought tolerant plants can make. So same zone, same month, 6.51 ETO. Now we're going to use a low water use planting with California natives. And they're going to be right in the middle of that. So they'll use 20%, 0.20. It's still going to be 1,000 square feet. So, but they're picking a different hydro zone. Same area. When we put that in the formula and do the math, 800 gallons for the month of July in the exact same area, simply by going with the low water use versus the high water use plants. So it really illustrates the value of selecting climate appropriate plants in our area. And you could water these plants for a whole month and your water bill won't even tick over a whole number. So potentially you could water these for free. Obviously you pay for all your water, but not even 1 unit of water on a water bill. So I think it really kind of shows you the value of the drought tolerant landscape. Now, let's just say you were ever in a circumstance where you're working for a client, you're designing a landscape and they want grass. It's one thing to tell them a story, to say, oh, grass is terrible, I hate grass, or blah, blah, blah. You want this, it looks better. Or those people who may think, oh, native plants, they're ugly, they're gray, they're disgusting, I don't like them, I want grass. Well, do you think if you showed them this example that it might change their thinking a little bit? Absolutely. So if you get familiar with these variables, quite quickly, you can just do a little paper calculation and you can say, hey, look, do you want, how much water do you want to spend? Do you want to spend 800 gallons a month, or do you want to spend 3,000 gallons a month? And maybe it'll help people to make good choices. So you can bring a lot of value to potential customers, your friends and family, if you know this information. Okay, so let's do a quick calculation. We want to calculate a basic landscape water budget. The ETO is 5 inches. The plant factor is 0.4. And the landscape area is 2,000 square feet. I'm just going to fast forward really quick. And here's our formula. So go ahead and I'll do the math myself as well. We'll see if we all get to the same answer. Okay. Who's got one? Who's got an answer?
2,480.
2,480. So we put in all our variables and do the multiplication, and you are absolutely right. 2,480 gallons, or basically, 2,500 gallons. So if you didn't get that and you don't know why, let me know. But the math is pretty straightforward and pretty easy. The nice thing about this is you can calculate any landscape in the world using this formula. So it maybe is a little bit simple, but it's useful because we can apply it to everything. Nicely done. Okay, any questions so far? We're all following along, and don't worry about, you don't need to be an expert in this yet, but we're going to be using this in future weeks. And so this is an important concept. Let's go ahead and take a little break. Let's try to take a 15-minute break. You can get up, stretch, and go use the restroom, get a snack. Normally we would take like a 20-minute break, but I would rather we take a shorter break, and we probably can be done a little bit early. If that's good with everybody, I think it's a better way to do it. So let's try to be back here in 15 minutes, and we'll continue on. So what's 15 minutes from now? 4:50. So we'll get going once again at 4:50. Sound good? Okay, we'll see you then. I'm going to stop sharing, and I'm going to close the camera, and then I'll be back at 4:50. We'll see you all then. Okay, everyone's doing good? Ready to continue? All right, me too. So we've covered the idea of the water budget. So that's just like if you're doing accounting, you come up with the budget. How much are you going to spend every year, for example? But then normally with accounting, you also have how much you've spent every day. And at the end of the year, you want to do some accounting. You want to make sure that what you actually spent matches with your budget. So the budget for water is similar. It's kind of the overall ideal. How much water does the landscape need? But there's a second piece, which is how much water do we apply? So it's two different calculations, but we need both of them. They're very much related, but there's a few extra things to consider when we think about the irrigation beyond just those three variables. So that's what we're going to explain now. And so I like to use the accounting analogy. You think about how much you had planned, and then how much you actually spent. That's what we're going to be looking at now. So when we talk about the amount of water we need to spend in irrigation, we want to subtract however much water we get for free. And that's from rainfall, precipitation. So remember in the beginning, when we were looking at the evapotranspiration data, we saw that normally we'll lose 30 inches, but we heard that we get about 10. So that doesn't mean we need to irrigate 30 inches. It means we need to irrigate the difference, which is 20. It's a little bit more technical than that because we get the rain at a time when we don't really need it because there's not a lot of evaporation. But in general, this kind of concept is wanting you to consider the overall amount of rainfall and can we use rain to reduce the amount of irrigation we need to provide. So they call the rainfall that supplements irrigation effective precipitation. That's the amount of water that enters the soil and is available to plants. It's less than the total rainfall because if it rains too much, not too much, but if it rains a lot, that soil is going to become saturated and any extra water goes down the storm drain and into the ocean. So it's not the case that every bit of water that falls on the property during a single storm stays in the soil. Some of it is lost, which is why we harvest it as rain in rain barrels. But any amount of water that does enter the soil, that's called effective precipitation, and we can subtract it from the overall amount of water that we need to irrigate. So the other thing we're considering is the irrigation system itself. And it's the case that there's no perfect irrigation system. There's nothing that's 100% efficient. No matter how good you are at putting the pipes and the sprinklers together, there's always going to be some inefficiencies. And there's two kinds of inefficiencies. And so we need to run the system for a little bit longer to account for any inefficiencies. And there's two metrics. The first is called irrigation efficiency. That's talking about the amount of water that is used by plants compared to the amount of water that is applied. And if you have any sidewalks going through your garden, or if you have these pop-up sprinklers that basically they're going from one sprinkler head to the next, throwing water into the landscape, there's going to be some water that doesn't go into the soil. Either it's going to hit the sidewalk and run off away from the garden, or if it shoots up into the air, some of it becomes mist and flies away into the sky. Or if you run them for too long, you're going to have it go down too deep into the soil and your plants are not going to use it. So all of those things are related to the irrigation efficiency. There's a separate type of efficiency, which is looking at distribution uniformity. And that's just a technical term that describes wet spots and dry spots. So if you have an overall, let's say 1,000 square feet, like the example, and it uses pop-up irrigation, all of those sprinklers, most of them will go out in a circular pattern. But if you have a bunch of circles in a square area, it's going to be very difficult to have perfect coverage that's exact in every square inch of that spot. You're going to have some areas that get a little extra water and some areas that stay a little bit drier. And that's okay. It's inevitable. It's impossible to be 100% efficient. But any amount of inefficiency means we have to water a little bit longer to make up for it, because we have to make sure that the driest area gets enough water to keep the plant watered. You don't really need to worry too much about these two different types, irrigation efficiency and distribution uniformity. The one we worry about the most is the second one, DU, distribution uniformity. And you can see some water budgets use IE, others use DU. We primarily use DU. And in later sections, we're going to actually learn how to measure the distribution uniformity. So let's take a look at the irrigation water formula. It will look similar to the water budget, but we will account for these extra variables. So here we take our weather, the plant type, the ETO, and the PF, plant factor. But we're going to be subtracting the effective precipitation. We need to do that before we multiply by the landscape area. And then any irrigation inefficiencies we need to account for. So the way this formula works, it's division, divides by a decimal. And because it could be the opposite, but they use division. Still not too bad. And then we need our conversion factor. So let's check it out. Remember going back to elementary school math, remember the order of operations. We always do what's inside the parentheses, and then we go from left to right. So we're always going to be multiplying the ETO times the plant factor first before we subtract the effective precipitation. So here's an example, and I guess it did it for us. Normally I would have an extra step there, but jumped right ahead. But that's okay. Let's just consider this example. We have the ETO 6.51. The plant factor is 20%. We get 0 rain. The 1,000 square foot landscape area with an irrigation efficiency of 0.75, 75% efficient. So when you calculate that all out, it comes out to 1,076 gallons. And we compare that to the water budget after a certain amount of time. Let's look at how it changes when we have drip irrigation. The same landscape area, the same month of the year, same plant factor. The efficiency is 0.81 instead. And just by switching from overhead irrigation to drip irrigation, the number of gallons used is 997 gallons. So how many total? Only maybe about, what, 100 or 200 gallons? Actually, no, looks like just about 100 gallons, a little less, is saved by switching from overhead irrigation to drip irrigation. But again, that big variable is going to become the irrigation efficiency. So let's give it a shot. Let's calculate the irrigation water requirement using the ETO of 5 inches. Plant factor is 0.4 or 40%. The landscape area is 2,000 square feet. We get 1 inch of effective precipitation, and our irrigation efficiency is 70% or 0.7. And here's the formula for you. I'll go ahead and work it out myself, and then we'll see what we get. Okay, who's got an answer for us? What is the overall irrigation water requirement? Hunter, go ahead.
1,771.
1,771, and then probably a bunch of decimal points. So yes, you're absolutely right. Way to go. You can see how you need to do the math inside the parentheses first, and then you can just treat it like a standard formula going from left to right. So there we go, 1,771 gallons. Any questions about the water budget or about the irrigation water requirement? It's pretty straightforward. I like it because you could almost have like elementary school kids doing it. And this is something that is a permit requirement for new landscape construction, but no one knows how to do it. Even the cities that issue the permits are totally confused by all this stuff. And it's unfortunate. It's not difficult to do. The part that everybody's confused by is taking gardening, which has always been kind of, qualitative, and turning them into numbers. The idea that now you need to know the name of the plant you're planting. Not only that, you got to be able to look it up and decide if it's a medium or a low water use. That's a new concept to a lot of people in the industry. It used to just be that you go to the nursery, you buy whatever looks good, you stick it in the ground, and there you go. But we can't do that anymore because we want to be responsible with the water resources. So in order to get the permit, the very same or similar calculations, they need to be done for every new landscape before that permit gets stamped. And a lot of people have difficulty doing so. So it used to be that the law was there, but the enforcement was not very rigorous. But now the enforcement is very rigorous. And so we need new people who know how to do that work. If you're looking for employment and you're wanting to work with a company that puts in new landscapes and you have some experience with calculating water budgets, you're going to be a very good candidate because that's something that not many people, including people who've done this for years and years, they don't understand it and they don't want to take the time to even figure it out. But it is an important thing to consider. It's not perfect. So let's talk about the couple of issues that go with it. It's not a perfect system, but it is the best we have. So I still think it's good to use, but here's what people say about it when they complain. Challenges with using the water budget system. First of all, you got to know the reference evapotranspiration. And so you need to look at the data. And the question is the data reliable? Because there's what the weather station saw, and then there's what it used to be historically. However, what if when you look at your site, there's something different? Like what if there is, I don't know, a cloud just hanging right over your one garden or something? Or like say there's some change in the sun and the shade conditions. Or like sometimes on Google Maps, you look at the map and today there's been construction, but the map doesn't show it yet. Things like that. What if the data is not accurate? That's a question. And what about the current temperature and evapotranspiration versus the historical average? If we make a plan into the future using today's average, that's going to change over time, especially as things get kind of hotter and drier. So there's some challenges there. Also, knowing the plant factor is not straightforward. You have that WCALS list. How did they come up with that list in the first place? Well, a bunch of experts sat around in a circle and went down the list of plant names and said, I think it's this, I think it's that. That's literally how they did that. It's not perfect. And there's some opinions in there. And some of the plants you think, why are they medium? They should be high. Or why are they low? Well, maybe they kind of knew what the system was for and they snuck in their favorite plants here or there. So that WUCAL system, if you really dive into it, may be a little bit questionable, but for the most part, it's the best we've got. New landscapes versus existing landscapes are not really considered. So if you put a plant in the ground on day one, you have to water it more when it's a young baby plant to get it established. And the opposite is true as well. If you have a very old, mature tree, it might be a medium water use plant by the book, but if it's really well established, it has roots that go all over the place. It can behave like a low water use plant. So this system does not account for the age of the plant. Also, it requires you to know your plants. You need to be able to identify them by name, to look them up on WUCALs. So if you don't have any knowledge of the names of plants, either the botanical name or the common name, you'll have a difficult time translating what you see with the actual number. And then finally, the idea of mixed hydrozones. It's very common in the landscape, especially over time, as you know, it's installed maybe by a professional, but then over time things live and die. You'll swap out some plants here and there. Eventually, most landscapes will become very mixed. And so you may have these low water use plants in your landscape, but they're not separated out by an irrigation zone. So they might as well just all be part of one big thing. There's a few more challenges to the system. And then the last variable, the area, you need to know the area. That's a lot easier to do than the other ones. You measure it. You could even measure it using Google Maps, kind of draw a line and it'll tell you the exact area. But you got to do some math and you have to do extra calculation. You need to make sure you exclude the hardscapes and any unirrigated areas. You can use a variety of tools. Google Maps is one, aerial imagery. Use a tape measure, use a measuring wheel. And even if you get really good, you can learn how many feet are your personal steps. Like for my body, I know exactly how many steps are 10 feet. And I can, down to about 6 inches, I can walk exactly 50 feet. So you could do tricks like that. With time, you get very good at measuring. But if you're a beginner in doing this, it may be more time consuming, a little bit of extra effort. Usually visual estimation is not effective. You can't really look and say, I think that's 25 feet. You're going to miss out on a lot. And squares are easy, but okay, how about we have this crazy oval shape or like a kidney shape? That's a lot more difficult to measure the area. So how are you going to do that? Can be difficult. Any questions about kind of the challenges of the system? Whenever I teach this class, I like to, I really appreciate when we have a variety of students. And some of those students really love this kind of system. And some you can tell are just like, that's crazy. It's too much work. I'm just going to go put my plants in the ground and just have fun. So I can kind of see both sides of that perspective. I'm curious what maybe you all think here today.
So for me, given that I've had the opportunity to design landscapes and implement certain landscapes with plants, my direction was going towards more of the drought tolerant, water smart plants. And so for me to do that, I have used locals and I've used the sunset. I have it right here, and I refer to those a lot. And so it all makes sense. And to be able to use this makes even more sense for me. And I think it's a great tool. And it's something that I will definitely take advantage of more often. And it looks like something I can actually use on the course as well at some point in my career. Yes.
Absolutely.
Sorry about the dogs. They just
No.
came in from the vet.
That's good.
If you hear them, sorry.
Yeah. Valerie or Hunter, what do you guys think about this idea in general?
Definitely, it's a lot to take in, but it is really interesting just because, based off like my interests and my hobbies, it kind of goes hand in hand and it kind of helps provide me with more additional information to kind of better my skills in certain areas. So besides, how much information it is very useful and interesting.
I like that perspective. How about you, Hunter?
I really like this method and could see how it could be very beneficial, especially for people commercially installing, and they could tell the consumer how much certain landscapes may cost after it's installed for water.
Absolutely. I think you all are kind of speaking to the same idea. And I agree with your perspectives, which is when you're done with work, you go home and you maybe have a little yard or a garden, and you're going to go just play in your garden. Are you going to be sitting down and doing a water budget? No, probably not. However, the concepts we talk about, you can still have them in mind, and you can pick drought tolerant plants. You can focus on efficient irrigation. That's great. But if you're going to go to the step of now getting paid to build gardens for other people, then you have an opportunity to use these skills, and you can save your client a lot of money, and you can do good for the local environment. And also you can make some good money yourself, because every dollar you save your customer, they should be willing to give you some of that savings, because as long as you don't take 100% of the savings, they're going to make money as well. And they're going to realize the savings year upon year if you install a responsible garden. So really knowing this kind of stuff gives you a valuable skill. The other thing that I like to tell the folks who maybe are a bit like reluctant is, yes, it seems like a lot of work because I'm introducing all these concepts, but all the stuff I've introduced is not that hard to do, and it doesn't take that long. Even in the time we've been here today, that amount of time, if you dedicated it toward one landscape project, determining a water budget and a irrigation water requirement, in the end of that couple of hours, you would have information that would be very valuable. And you could make those 2 hours well worth your time with the amount of money that you earn doing this kind of work. And of course, if you got good at it and you did it regularly, it wouldn't take you 2 hours, it would take you 2 minutes. And so becoming very familiar with this system eventually is something that becomes very important and valuable. And it's where the future is going. So whether we like it or dislike it, it's going to be the kind of thing that the professionals are going to all be using and relying on. The more you understand it, the more advantages you've got. But at the same time, I always don't go crazy on your own personal property if you don't need to. Nobody's going to be, kicking down the door saying, show me your irrigation water requirement in gallons. And that's not the purpose. The purpose is to help come up with useful information, and mainly for these new landscape installations. As JR mentioned, also though, if you're on like a golf course or any kind of like big landscape, large area, if you could reduce your water use by 1% with just a little bit of calculation in a couple hours, and for a year you save 1%, that's going to result in tens of thousands of dollars of savings. So it's well worth your time and effort. Even some of the municipal golf courses might not pay a water bill. I don't know, but it's still well worth your time, because one way or another, eventually someone's going to watch and you're going to have to pay for all the water you use. So well worth the effort, and it helps us just know more. I also like keeping my math skills a little bit sharpened. Otherwise you forget them. So let's move on to the next section here. A couple of examples with water budgets. So there are different types of water budgets, and they're used in regulation and rating systems. And they always compare the water allowance and the water requirement, which is basically what we did. The water allowance is like the water budget, and the water requirement is like the irrigation requirement. So irrigating to a water budget is what makes you a water manager. So when you're working out there and you're in charge of a landscape, you can have the job of water manager. You can be certified as a water manager. And in order to be a water manager, you're well aware of the budget and the use, and you're making sure the use is appropriate and not exceeding the budget. So there's several different examples of water budgets. The primary one we use in California is this one here. I mentioned it before 2 weeks ago, the Model Water Efficient Landscape Ordinance, MWELO. And just going to show you real quick. I always think it's worth the effort. I had all the other ones pre-saved. I didn't have this one pre-saved. But I'll show you the formula, and you will find that it's quite familiar to you. Every city will have a different ordinance, so it's up to the city to enforce, but they all basically follow the one state standard. And it's the requirement for all new landscapes, commercial and residential, based on the square footage. So if you're doing a small little installation, you don't have to worry about it, but they're always shrinking that square footage. And I'm trying to pull up here the particular part that is showing the formula. And this is the thing that gives everybody the most trouble. If I can't find it in like a short amount of time, I'm going to save it and bring it up later because I don't want to waste your time. Yeah, I will share it in a future class meeting because the formula is almost exactly what we did here today. And it has I actually like it a little bit better than this one, but it has a few more details. You can be very accurate. So MWELO is the California state standard. Other states do not have a water efficient landscape ordinance. We do, and other states will adopt California's model eventually. But there are also state or federal EPA water sense budget tools. There's the simplified landscape irrigation demand estimation. And then California has a certification, CLCA water management certification program. And you can become a certified water manager if you are really excited about this type of work. It's very important work and we don't have enough of them. So we need more water managers. Okay, well, let's do some review questions here really quick. And I think, yeah, it's just 2 pages of them. Let's, we don't need to take turns, but we'll do a quick little review. And we can work as a team. So we're a team here. We're all going to just try to get to the answer together. Number 1, what is a landscape water budget? And what are the 3 elements of a basic landscape water budget? Who can start us off? Just feel free to shout it out. No need to raise your hand or anything.
A water budget is basically the estimate of how much water is needed to maintain a healthy landscape for a given period of time. And then the 3 elements are weather, plant type, and area.
There you go. Perfect. Nicely done. Okay, true or false? ET changes as the weather changes and is affected by factors including solar radiation, air temperature, relative humidity, and wind speed.
Is it true?
It is true. True and false questions are terrible because you overthink it. You're like, yeah, that makes sense. But also, is every one of those things part of it? You're looking for the trick. So here, when they ask true or false, don't think too much about them. What does ETO stand for? What is it referring to?
The reference point for landscape plant water use calculations.
Yes. And so we call that reference evapotranspiration.
Mm.
The plant factor is expressed as a percentage of blank.
Evapotranspiration.
There you go. Good job, Hunter. And it would more particularly be reference evapotranspiration. So ETO. Plant factor is a percentage of ETO. Here's a fun one. Name a few identifying characteristics of low water use plants. I think I mentioned like 5 or 6 of them.
Thick leaved plants, smaller leaves.
Small leaves, thick leaves, succulent, white color, little hairs. There you go. What is a hydrozone?
An area in which it is a group of plants or area that is specific to one type.
One water use type
Right.
and also irrigated together.
Mm.
That's the important piece. Okay. How do you calculate a basic landscape water budget using ETO, the plant factor, and the landscape area? If you had to tell someone else how to do it, what would you say?
You multiply them all together and divide them by 0.62.
That's almost perfectly right. You multiply them all together and you multiply by 0.62. So for the water budget, it's all multiplication. Nicely done. Now, what's the difference between a basic landscape water budget and the amount of irrigation water to apply? What else are we considering with the amount of irrigation water to apply that is not considered in the basic landscape water budget? two things in particular.
Would it be the plants, like the type of plants, and then the weather?
Well, that is part of the water budget, the weather in ETO, the plant factor. But there's one other thing where we need to irrigate less. And there's another element that means we need to irrigate more when it comes to the irrigation water requirement. Do you remember what that is?
The rainfall
Yep. And
and um
so if there's rain, we have to irrigate less
mhm,
than the water budget. And we're going to have to irrigate more to compensate for something.
like drought. Not drought.
Help her out. Hunter, go for it.
Water inefficiency, watering inefficiency.
Yes. So the efficiency of the irrigation system, we have to water extra to compensate for a system that's not efficient. And we would water less when, I might have said water less for irrigation efficiency. We water more for irrigation efficiency. We water less for precipitation. And those are two other factors. Remember, it was EP and IE. Don't worry about memorizing the formula today, but we're focusing on the concepts. Okay. California focus. What does CIMIS stand for? And I'm going to change that question. What do you use CIMIS for? Do you remember what CIMIS tells you? What that's all about? CIMIS. What is that? I don't care what the thing stands for. I want to know what it tells me.
It tells us how much water certain plants need and how much they transpire.
That is the other one. So this was the first one we looked at.
The maps.
Exactly. Yeah. So CIMIS is the, I don't even remember, California Irrigation Management Information System, I believe. So it's telling you how much the reference ETO is for a certain area in a certain month. How many inches of water have you lost? And I remember it. I think of CIMIS as like a satellite. So it's the kind of weather that comes from satellites and from our weather stations. So the next one, California focus. What is the peak irrigation month for most climate zones in California?
July.
July, absolutely. Good job. And then now, Hunter, here's the other one. What does WUCALS stand for? And I'm going to change the question. What does WUCALS tell you?
How much water plants need and transpire.
Exactly. So here's where we have the water use classification of landscape species. But I think that's such a terrible acronym. It doesn't have a P in there for plants. Shouldn't it just be like the PF system or something like that? WUCALS, just remember water WUCALS. So there we go. That's kind of the introduction to this concept of water management. And it's taking something that's a little bit environmental and kind of like we see it, we interact, but turning it into a number. And once we turn it into a number, we can actually make an improvement or at least make an experiment, and we can run two things side by side, and you can say mathematically if something is better or not in terms of water use. And that's a huge thing that we need to do more often in our mainly professional landscaping. So I'm excited to be able to share with you. And we're going to keep going in this process. Next week, we're going to cover 2 more topics asynchronously, and then we'll meet back up in 2 weeks. But before we sign off and say goodbye, I just want to check in. Does anyone have any questions or any review? Maybe we could just share like one thing from today's topic that you think you thought was good, or that you're gonna keep in mind as you go about your day. If there's anything that stands out, I'd like to hear it now. Feel free to share if you've got one.
I just wanted to say that, so ever since like learning about this topic, I've noticed a lot more places that have signs like, oh, don't drink like the water, it's irrigated. And before I didn't really pay attention to it, like I didn't really understand what it meant or the importance of it. So I just think it's really cool now that, going in detail about it, there's more value added to it. I just think that's really interesting and cool. And I notice it more, like the places I go to, and then, or if I see people like wasting water and I'm like, shame on you, I don't know. That's just something that I've noticed.
Yeah, I agree. Every class that we have in our program, I think is like that. And this one's focused on water. So you see all the water stuff. When you take the plant identification classes, you start to identify every plant around you. And I'm glad to hear that, because that means that it's working. And it's one of the things that we need more people to do. So just by paying closer attention, you're helping out big time. Very nice. Anyone else?
I just wanted to add to that. Yeah, I'm just definitely more aware since, taking plant ID classes, this class, just definitely more aware. For example, the tomato plants, I decided I've got to empty my rain barrels. So I just went directly to those and started watering different plants. So it's definitely created more awareness, and we start practicing those day-to-day habits that we are now learning about, and hopefully we'll stick with. And but yeah, this is good stuff. This is really good to understand the calculations, everything that affects the water, the weather, everything. So
awesome. Very good. A quick little reminder: if you ever collect rainwater, use it. Don't save it like money in a bank or something. Use it as quick as you can. If you have rainwater, don't turn on the hose. Use the rainwater first. And there's nothing worse than if your rain barrel is full and then it rains. You're saving nothing. So you need to have used up the rainwater in order to collect more. So don't save it for a rainy day. Hunter, any key takeaways from today?
I think both the websites had a lot of good information, and I also found the math part interesting, and would like to know how they got the numbers for each plant.
Yes, I'm right there with you. I know some of the people who were at the table when they decided the numbers, and now that I've used the numbers in some detail, I have some guesses on why they picked certain things for certain plants. But it's an interesting kind of a challenge, and nonetheless, it's great to have. And if you're going to be doing this as a job, you definitely want both of those websites saved on your internet browser so you can go back to them quickly, and you can answer if there's a little question that pops up, you can answer it really fast. It's a great resource to know and to have. So there we go. Very good. Well, we're going to be able to end quite early today. I'm excited to do that. This is a difficult topic, so it's important that we don't try to cram too much in. We already did enough today. And take some time to think about it, and we'll see each other online next week. And then we'll be back in 2 weeks in person. Sound good? Okay. Take care, and thank you, everybody. Have a good one. Bye-bye.